whenever we do application of derivatives, there are the problems related to increasing and decreasing functions. Sometimes it becomes difficult how to decide a given function is increasing at a given point or decreasing at a given point. So there is some criteria to decide increasing and decreasing functions. In today's video, let us learn how to decide and how to do the calculations related to increasing and decreasing functions. Here we got a graph. Let us say this is y equals to f of x r over r, like this, y equals to f of x. So I got the two graphs here, and a tangent is drawn at a point A. Here is a tangent is drawn at the point A. Here is a inclination of tangent, that is equals to theta, is nothing but acute angle, and here is the inclination of theta in the right side of the graph is obtuse angle that lie between 90 degree and 180 degrees. Here the theta is in the left side, the theta is acute angle and theta is less than 90 degrees. And we know that m equals to slope of tangent. And slope of tangent is given by tan of theta, tan theta. And theta is the acute angle, therefore m equals to positive. Here is also m equals to slope of tangent. And m equals to tan theta, but theta is obtuse angle, therefore m is negative. Whenever the theta is obtuse angle, the tan theta value is negative. Example, tan of 90 plus theta. So the result of tan theta is negative. To avoid confusion, let us call it as a graph 1 and call it as a graph 2. In graph 1, we got slope of the tangent positive, and in the graph 2, slope of the tangent is negative. We know that slope of the tangent is also given by m equals to dy by dx. It can also be written as f dash x. So in the graph 1, the slope of the graph is greater than 0 because it is positive. In the graph 2, m equals to dy by dx equals to f dash x. Since slope of tangent is negative, therefore f dash x is negative and f dash x is less than 0. In such conditions, the graph 1, that is y equals to f of x, is said to be increasing, function. And the graph 2 is said to be decreasing function, that is graph 2, that is y equals to f of x, is decreasing function. So what is the condition? The important condition for increasing function? The important condition for increasing function is dy by dx greater than 0. And for decreasing function, the important condition for decreasing function, what is the condition? Dy by dx less than 0. Suppose this is the point A, x equals to A, and the given graph is, already we know that y equals to f of x. Therefore, this point A, this is the point A, and coordinates of point A will become A comma f of A. These are the coordinates of point A. Now, let us draw a vertical line, left side of A and the right side of A. In both cases, equal distance, that is equals to delta. So this distance equals to delta. In diagram, they are looking something smaller, larger, but they are equal because it is a rough diagram. So this is nothing but x equals to A. Therefore, neighborhood point, let us call it as a P and Q. So P and Q points are the neighborhood points. What can be the coordinates of point P? The coordinates of point P is nothing but A minus delta, and coordinates of point Q nothing but A plus delta. Delta is very, very small value. Point P and Q are called neighborhood point. And at the point A, you see at the point A, capital A, we have drawn the tangent. So tangent is drawn at point A. Tangent is drawn at a point A, and point P and Q are neighborhood points. Coordinates of point P is nothing but A minus delta, comma 0. And coordinates of point Q, that is A plus delta, comma 0. They are neighborhood points. Call this point P equals to x1 and call it point Q as a x2. In the maximum books, these points are called as x1 and x2. Implies x1 equals to A minus delta and x2 equals to A plus delta. From diagram, it is clear that x1 is smaller than x2 and given function is y equals to f of x, implies f of x1 smaller than f of x2. So if f of x1 is less than x2, then given function f of x is increasing function. After all those discussion, let us define what is exactly the increasing function. Definition of increasing function. We have a given function y equals to f of x, for which we have drawn this graph. This graph stands for y equals to f of x. And we had x equals to a. So this was the x equals to a. This point is x equals to a. And there is some neighborhood point such as a minus delta comma 0, a plus delta comma 0. You see the coordinates of point P are a minus delta comma 0 and coordinates of point Q are a plus delta comma 0. What is delta? Delta is any number which is greater than 0. Delta is any number which is greater than 0. And if x1 equals to a minus delta and x2 equals to a plus delta, and if f of x1 less than f of x2, then we say the given function is increasing function. This is the definition of increasing function. Similarly, now we can define the decreasing function. Y equals to f of x. Suppose a decreasing function. Then what are the conditions? The conditions are, first of all, select a point at which the tangent is drawn, that is x equals to a, at x equals to a, we have drawn the tangent. We have to decide whether the function is decreasing at x equals to a or not. If it is decreasing function at x equals to a, then what are the conditions? We have selected here the point x1 and here is the x2. So x1, x2 are the neighborhood points such that delta greater than 0. And from the figure it is clear that x1 is smaller than x2. And how to get this point here? X1 equals to what? X1 equals to a minus delta. And what is x2 value? That is a plus delta. A plus delta. x2 equals to a plus delta. And if it is a decreasing function, then f of x1 greater than f of x2. So a function is decreasing function at x equals to a, and if x1 and x2 are in neighborhood, then f of x1 greater than f of x2. This is the definition for decreasing function. For increasing function, f dash x greater than 0, that is dy by dx greater than 0. Similarly, for decreasing function, f dash x less than 0, or that is dy by dx less than 0. So these conditions also are the conditions for increasing function, and for decreasing function. Sometimes we use even another technical word, that is monotonically increasing and monotonically decreasing function. In case of monotonically increasing function, we are given interval AB and we are having x1 smaller than x2 such that f of x1 smaller than f of x2, then we say it is monotonically increasing function. And for monotonically decreasing function, the condition is reverse, that is f of x1 greater than f of x2. For monotonically increasing function, even we can use this condition, f of x greater than or equal to 0, and for monotonically decreasing function, even we can use this condition, f dash x less than or equal to 0. So this is what difference between monotonically increasing and monotonically decreasing functions. Example number 1. Find the value of x when f of x equals to 3x square minus 12x plus 5 is increasing, and second question is decreasing. So solution, first of all we have to see what is f of x, that is 3x square minus 12x plus 5. Step 2, find the dy by dx, that is differentiation, so that is equals to 6x minus 12. Now if the function is increasing, case number 1, for increasing function, f dash x greater than 0, therefore 6x minus 2 greater than 0, therefore 6x greater than 12, therefore x is greater than 12 upon 6, x is greater than 2. Therefore the function is increasing. Function is increasing if x is greater than 2. Now second case, the function decreasing. We have to find the value of x for which function is decreasing. So we have f dash x, that is 6x minus 12. For decreasing function, f dash x less than 0 implies 6x minus 12 less than 0. implies 6x less than 12, implies x is less than 12 upon 6, x is less than 2. Therefore, function is decreasing. Function is decreasing if x is less than 2. Example 2. Show that the function f of x equals to x cube plus 8x plus 9 for x belongs to R is strictly increasing. We have the function f of x equals to x cube plus 8x plus 9. So f of x equals to x cube plus 8x plus 9. F dash x equals to 3x square plus 8 implies 3x square is greater than 0 for all x belongs to R, and 8 is also greater than 0, implies f of x is greater than 0. Let x1 belongs to R, x2 belongs to R, then and x1 is smaller than x2 implies f of x1 smaller than f of x2 implies f of x is increasing function, strictly increasing function. Example 3. Test whether the function f of x equals to 2 upon 3 x cube plus 2x square plus 2x plus 6 is increasing or decreasing for all x belongs to R. Solution. First of all, take f of x, that is 2 by 3 x cube plus 2x square plus 2x plus 6. After that, do the derivative, that is f dash x equals to 2 by 3 into 3x square plus 4x plus 2 plus 0. Then simplify it. 2x square plus 4x plus 2. We can take 2 common. So x square plus 2x plus 1. Therefore, the f dash x equals to 2 into x plus 1 whole square. Now, f dash x equals to 2 into x plus 1 whole square. Case 1, if x equals to minus 1, then f dash x equals to 2 into minus 1 plus 1 whole square equals to 0. Therefore, f dash x equals to 0 if x equals to minus 1. Case 2, f dash x is greater than 0 for all x belongs to R implies from case 1 and 2 f dash x greater than or equal to 0 for all x belongs to R. Therefore, given function f of x is increasing function.